Bounty hunters. We don't need that scum.
Yes, sir.
No disintegrations.
As you wish.
I try to cut the ambient noise down by as much as I can. My goal is to turn this into 19 of these. I've already done all the CAD drawings, you can see that here. Anyway, the fixture for how to do this. I'm using the painter's tape and CA gel. Actually, this isn't CA gel, I'm not sure what this is. It's Loctite Go-To and may actually be the cyanoacrylate, but it's actually got a different texture to it. But using the painter's tape that I have on here, I'll put a layer on here and then we'll actually CA gel this down. Load this and indicate it into the machine. And then I've got a program that actually cuts out 19 of these. I've ran it once so far and it actually worked really well. Although getting all of the tiny detail, each of these takes about 45 minutes or so. The entire process to do all 19 of them was about 12 hours. So it's a long time running the machine. So let me bring in and we'll kind of go over what's the next steps. I've already got the layers down on the fixture plate. And we'll kind of go over what I've got for this here. All right, so for anybody that's just joined in and doesn't really know the rest of this project, this here is an original World War I English or British flare gun. It was used as the basis for the Boba Fett EE-3 in Empire Strikes Back, and then another version was used as the basis for the one in Return of the Jedi as well. There's pretty significant differences though. For this particular one, it's for the Empire Strikes Back. This is a recreation of what was an antenna plug for a 60s, 70s era radio. Basically the whole thing folds up. These holes would actually come through and the whole thing would end up looking more similar to this, you know, once it was folded in half and everything. So what I'm trying to do here is actually recreate all of the features that were on those originals as they were actually used to just glue onto here to make this antique weapon look sci-fi. This fixture plate that I've made, this is actually a Korean style acrylic countertop. Stardust Industries, it's in the city here locally, and they are kind of I call them sort of the Goodwill of remodelers. So as a remodeler has a bunch of semi-good things that they've pulled out, you know, remodeling a kitchen or whatever, they can take it to this place and donate it. Then they actually sell it for what ends up being extremely cheap in a lot of cases. So I got a fairly large piece of this for $5. It's actually really nice. It machines really well. It's a little hard and brittle, but it's still a plastic, so it machines fairly easy. Out of this piece, I had enough left over to make this countertop for my lathe tools toolbox. So this is my toolbox. It has mostly all of my lathe tooling and all of my drill bits and everything on top of it. And now it's got a nice acrylic countertop top. And then of course my Wilton. All right, so back to here. First thing we have to do is make sure that this has a really good clean surface. So I'm going to kind of inspect, and I think I'm going to start with this side here. And initially I'm just going to hit it with some Windex and a shop towel. And that's just to get the bulk of any dust, dirt, or oil off of it. Doing both sides, mostly just to make sure I don't get any on it from the other side. So next, I don't want to get any grease from my fingers, so I'm actually going to go ahead and put on some gloves. grab a fresh towel and use a little bit of acetone. So the idea is I just want to make sure that the tape gets a really good solid bond. And because I'm not trying to conserve anything here, I'm going to go ahead and use one more dry one and get a good white. Get any wet materials off. Next up is just the tape, and here we're just going to go for coverage, end to end. And the next step here is actually a fairly important one. I'm going to use a little, it's just a popsicle stick, a partial popsicle stick. It's, I think this came in a 2-part epoxy thing or something. I usually end up using plastic to do those stirs. So this is an extra one, and I'm just going to use it to go over the tape and make sure it's got good solid contact. Alright, the next piece, I want to come by and just do some trimming to keep everything a little bit tidy. Alright, next up is the glue. This I kind of use this little shape here to make sure I have air exits. So that the glue doesn't seal itself in. Alright, so now I'm just going to be flipping this over and setting it on top of here. And then I've got a few chunks of heavy steel that I can put on top of it to kind of act as a clamp. What I'm doing with my fingers here on each side is I'm just trying to keep the edge of this in line with these holes, because I know the holes are lined up well on the table of the CNC machine, and that will help me when I go to line everything up. Last time I did this, all I did was put bolts in each end here, pull it down so that it was hit up against those bolts, and I was within 10 thou end to end on here. So I don't know if I just got really lucky on that one, or if this technique worked really well, but just keeping it in line with the holes seemed to work really well, at least that time. We'll see if it works again. Alright, it's now been a couple of hours, and any place that the glue is sticking up, it's no longer tacky. So we're going to call it good and get it over onto the mill. push this side that way. Alright, let's see if we got that any better. Yeah, looks like no. Or maybe we did. Like, I don't know. Alright, now that everything's bolted down and secured to the table, we've got to indicate this guy. So in Fusion, I've set this corner here as my main point, so we want to locate that corner. And we can set G54 to there. First step is we're going to want to select tool 1, and we'll want to tell the machine to change to it. And then we'll want to do that cycle. Next, I'll manually jog the table until the probe is close to this corner. I almost forgot, because we're on duct tape and plastic, there's no connectivity between here and the table and the rest of the machine, so it won't ever actually complete that circuit. I have a trick for that. Yeah, so using a wrench allows it to complete that circuit. Alright, so now we want to get actually on the center of that ball, which that ball is 20 millimeters, and I just have a note here of how many thousandths of an inch half of 20 millimeters is. 10 millimeters, 1968. So what I'll do is I'll go to the x-axis, and we'll start moving it here. 1968. And now you can see the line of the part is in the center of the tool, so we'll know that that is our x-axis. So next up is do the same for y. I won't show all that, it's basically the same thing. Alright, so now I've set this side and zeroed those out. I've also moved 1/4 of an inch in and 1/4 of an inch in both directions. The ball on this edge finder is spring loaded for going, from the side. But straight down, it is actually not spring loaded. So the way I take care of that is I'll use some paper as kind of a landing pad that I'll know that I'm actually really close, and then I can go down to just a fine adjustment and just come down until it touches. And that gets me my coordinates. I'll pull those off of the computer and I'll plug those in as my 0 point for G54. Going to X0, Y0. Only 1/4 of an inch, it happens almost instant. Now I can look at my X and Y machine offsets. This is where, at least what I use for setting up G54 on this machine. Alright, so I just wrote down my X, Y, and Z for what G54 is going to be. This is what I used on the last run. They're fairly close, but not quite the same because it didn't have everything lined up exactly the same. Now to set this, I'll go into set. We're going to page down, and then from the manual, you look up which settings correspond to G54, X, Y, Z, and A. A is for if there's a fourth axis, which I do not have. So we want to change these to our new numbers. $33109. These numbers are in how many tenths of an inch. So putting a decimal point here is not a valid number, at least for the input. And again, that's just something you have to get out of the documentation. This is negative 76976. Negative 27174. All right, now my G54 offset is set up. So now what I'm going to do is go back to program. I'm going to do a G53, which is how I access the machine coordinate system. And we're going to go X0, Y0, Z0. And then run that. Now that we're back to machine 0, machine is 000, our universal is off by something close to actually exactly what our G54 is. So this we need to set back to 0, that way G54 will move everything away from that. And actually I should say it's the opposite of what G54 is right now. So we're going to go to the universal screen here, and we're going to zero everything out. Alright, so these are both 0, and our G54 is set. I've got my setup sheet here. I've already been through it. All of my tools are already preset, and everything's ready to go. Through at least the first tool change, but from here on there's not much to see for probably the next 14 hours. Let's see how it goes though. Here it is is just a little over an hour and 21 minutes into it. And it's starting on the third one, and they take about 30 minutes or so each. So here in the next 8 or 9 minutes, I should be done with this one. We'll check in another couple of hours and see how it's going. Alright, here we are just about 3 hours in. Just kind of finishing up the fifth one. We'll see how it goes here in a couple more hours. Right about 6 hours in, and on the 12th or 13th one, we're keeping up about 30 minutes for each of these operations. Now 11 hours in, and it's doing the small holes. Actually getting fairly close to the end. Probably got another 2, maybe 3 hours left. Guesstimated 12 to 14 hours. It may be as many as 15. Turned off the coolant here so you can kind of see what was going on. It's actually, we're up to 12 hours and 3 minutes. And it's putting in the fillets in the corners on the inside. They should be rounded. This is a little 1/8" ball nose end mill. Or no, this is actually the parallel path. This is cutting the curve spot. So this actually just runs back and forth like this constantly until the curve is in. And it's a little 1/8" end mill, like I said earlier. Alright, we'll be back again in another hour or two. I got down here just in time. I almost got the tool change. Just got the end of it. We're on to the engraving part. We're actually getting really close to the end. It'll be the engraving. There'll be one facing pass to clean up the burr that this picks up. And then it's going to start back on the 1/8" end mill and cutting each of the individual pieces out. This operation takes about 15 minutes total, so I was able to just stay here and wait for it to get to the last one. elevation is a 7-degree angle put on the inside portion. Just missed the tool change, and we started on the 1/8 inch slotting to actually just cut everything out. So it's just going to run circles a little bit lower each time. And there you saw a little piece broke off. Scary if the tool broke there for a second. We're now just shy of 15 hours in and coming up on the halfway through the final operation, getting this completely cut out. Every once in a while, it seems to get some vibration and pops that outside section out like that. But this is the stage. We're finally coming down to cutting out the very last one. I think it's got at least, oh, that was the end. We've got some chamfering to do, clean up all the edges. This will actually go probably the last 20 to 30 minutes. We'll go ahead and watch one of them complete. So this just breaks the sharp edge off of the top of those 4 pins. The sharp edge out of the square holes. Looks like it's held pretty well. You can kind of see here where it's been soaking in coolant. It's kind of wrinkled a little bit, but it never really soaked up underneath. Alright, a little bit of sandblasting and then off to be anodized. Get all these out of here. So I'm by no means am I an expert in this process, and one thing about this, the only high tool pressure operation on here is really the facing operation. But the glue that I used, this go-to glue, it's a little different than cyanoacrylate. Cyanoacrylate, when it cures, it's actually really hard. This stuff is actually flexible, almost like a silicone or something, but it does seem to hold at least well enough for this job. So I guess, without doing some more testing and whatnot, I would recommend this as something to test. I bought this because it was in with the rest of the cyanoacrylate glues, and it was the largest bottle they had. I knew I was going to need a lot, and I grabbed it, not really realizing that it wasn't what I expected. It still worked though. Those are the parts that were made. This is the fixture I used and the process I used to actually make it. I hope you learned something. I know I definitely did. Something I've never done before. That's really easy for me to say when it comes to the CNC machine, seeing as I really haven't done any of this before. Thanks for watching, and please like and subscribe if you find it interesting. I'll try to publish more videos, mostly pertaining to machining, CNC machining, manual machining, any kind of metalwork really, some welding, and anything else that I feel like trying to learn how to do. All right, thank you. Signing off.